So another topic that we're going to talk about in this particular section has to do with creating a scatter plot, coming up with the linear regression line that models the data from the plot. Kind of like what we talked about at the very beginning video of this section. So for that purpose, we're looking at this example here that says, is there a relationship between wine consumption and deaths from heart disease? So over here in this table of data, we have data given from 19 countries, and the leftmost column is listed as the X, and that is where the liters of alcohol or the amount of wine that you drink comes into play. And in the rightmost column we have the deaths from heart disease. Now you're already told that the wine value is my X and the deaths from heart disease is Y. The first question I want to ask you then is, okay, well, why do we then consider wine consumption to be independent and deaths from heart disease to be dependent? Why would that be the case? Well, when I do independent and dependent, I tend to go backwards, and I start from the dependent variable. So deaths from heart disease then depend on the amount of wine I consume, and that makes sense. Okay, so that's why the deaths from heart disease is dependent and the wine is independent in this particular study. So we're going to create a scatter plot representing the data that you see here in this column, or in these two lists. And we're going to let the X variable, or my independent variable, be L1, and the dependent variable be L2. In other words, the data in this column is going to go into list 1, and the data from this column is going to go in list 2. Okay, and that is generally how you set it up in your calculators. So I want you to get your calculator, and before we ever do anything, we've got to turn on a particular statistic in our calculator that isn't already on, or is not normally on unless you turn it on. And it's called the diagnostic. So we're going to turn on the diagnostic using the catalog function of our calculator. So you're going to hit second 0, and that enters into this catalog here of commands, and I want you to hit the X inverse button, and it's going to quickly take us to the D portion because the catalog is alphabetized, and I am going to arrow down all the way to diagnostic on. Okay, so I arrowed down, and you can see here that my black arrow is facing diagnostic on. I'm going to hit enter. It brings me to this home screen, and I hit enter one more time. The calculator comes back and says, okay, diagnostic is on. The diagnostic has to do with the correlation coefficient, and I'll show you what that means in a few minutes. Now let's go back to that list of data we were talking about. Again, I want to enter this set of data into my calculator, and I'm trying to make it so you can see it all. And the leftmost column is L1, the rightmost column is L2. So let's go look at that really fast. So to get to the lists in your calculator, you're just going to hit Stat. So the button Stat brings me to the statistics portion, and I'm going to edit. So we choose option number 1. I'm going to edit the lists that are there. Now your lists you should have L1, L2, L3, and so forth listed on this screen. You may or may not have data already populating the L1 and L2. I do already, but I want to show you how to get rid of that data if you want. So if you'll look at my L3 over here, I want to clear, and I want you to understand, I want to clear the data that is under L3, that is in the L3 column. So I'm over here, and I can switch back and forth from these columns by arrowing left and right, and when I push the up arrow, it brings me to the heading of that column, and I hit clear. Please don't hit delete, or you're going to delete the entire column. When I hit clear, it got rid of all of those ones below my L3. So if you have data in your L1 and L2, clear it out, and then what I want you to do is go back, or wherever you were at, and I want you to enter all of the data from our independent variable in X1 and in L1, and all of the dependent data in L2. And you're going to use this list here to be able to do that. Okay, so hopefully you have all of the list in there. You should have 19 entries for both L1 and L2. In order to create the scatter plot or the scatter diagram representing the data that you see here, we have to go turn the plot on. So I am going to go to my graphing portion of my y equals portion of the graphing calculator. So there's two ways to get into the plot. This is just the way I do it. I'm going to go to y equals. And if you notice right above the Y1 entry that I have here, my word plot 1 is highlighted. And if yours is not, in order to get it highlighted, you just arrow up, you hit enter, and you arrow down, and your plot should now be turned on. The next thing in order to plot this data is to make sure that the data is going to show up in the window that we're looking at. Your calculator's window default size is probably not going to be big enough to look at the data to be able to show you the data we were plotting. So to easily manage the window, I would come over here to our lists. And notice that, remember, this column right here represents the X values. So I'm going to adjust the x-axis to show me values along that are occurring here in this column. The smallest value I have is 0.7, so I'm going to start with x being 0, and the largest value that I see over here is a 9.1. So I'm going to look along the x-axis for values that are between 0 and 10, and I'm going to leave the scale by 1. Now for my y values, these are the values that you see on the y-axis, right? So I need to be able to go from the smallest value is 71, and I'm going to just let that be 0. The largest value that I see over here is a 300. I'm going to go just a little past that, so I don't know, let's go to 325, and I'm going to scale this by 25s because I don't want to see 325 tick marks. So that's the scale I'm going to use on my graphing calculator. When you come back here, we're going to go to Window. Window is how I adjust the size of the window. We said already that I'm going to let the x value be 0, the min is going to be 0, the max x is going to be 10, scaling of 1. The min y is 0, the max is 325, scaling it by 325. Once I set the window up like this, I should be able to see all of those plots. So you can go to Graph, and all of those green squares there represent the data points from the list that we just created. So here's my scatter diagram. And when you look at this scatter diagram, you can see that the general shape of my scatter plot is kind of linear because it's kind of all coming in a line, you could kind of say, and it is decreasing, right? So I have a general idea then that I'm going to be looking at a linear regression that is going to end up having a negative slope. So how do I come up with the line of best fit for this data? Well, we let the calculator do that part again. To do that, we go back to the Stat menu. This time I'm going to calculate, so I'm going to arrow over to Calculate. And starting about option number 4, you see that there are many different regression choices for the function that I'm looking at. We are looking specifically at a linear regression, and that's why we're going to choose option number 4, because our data lined up like a line. So the screen comes up to look like this. Yours might be a little bit different, but this is close. X1 is our independent, and it's being called from list 1. The y or dependent variable is going to call from list 2. And the next option that I have on my calculator is where do I want to store this regression equation once I get it created? Well, the nice thing about this is I can store it directly on the y equals and not have to transfer any information. So to get it to be stored there, I arrow down to Store Regression Equation and I choose vars on my calculator. I'm going to arrow over to y vars, and I am looking at a function. And so you see the list of possible functions here. I want to store it on the y1 in my graphing in my y editor basically. Now that I've chosen where I want it to store it, let's calculate it. So I arrow down and hit enter. And there you go. there's the equation representing a linear regression. Now the a, which is going to be my slope, right? Because a is the coefficient next to x, right? It becomes our slope. It's going to be negative 22.97, let's say. And the b, which is my y-intercept, is going to be 260.56. Now this r squared and r, this is the diagnostic part that we turned on. R is called the linear coefficient. And when you look at R, even though it's negative here, you're looking for an R value to be close to either positive or negative 1. The closer it is to positive or negative 1, the better your line is. If this value is close to 0, then that means that the line you created doesn't really fit the data you're looking at. So you're looking for an R value that is close to either positive or negative 1, and that's going to tell you whether or not you've done whether or not your equation does a good job matching the data that you've collected. Okay, so I'm going to drag this over here and we're going to keep a hold of that equation for now. I told you that I had my calculator automatically put that equation over here on the y equals, and if we go there now, you'll see that it is listed in fact on the y1. So I'm ready to graph it, and I can come over here, and when I graph it, you'll see that my calculator is now drawing this blue line, which is given by the equation that we just created. And that equation is the linear regression equation that models the data for the wine consumption and heart disease. So I'm going to drag that off as well. So we've done a couple of things here, and we've created the line of best fit, and we also graphed it so we can see that here. Now let's talk about the line of best fit also and write it in its function notation. So remember that A is going to be this portion and B is going to be this portion. So to write that linear model in function notation means we just stick it with an f of x equals negative 22.97x plus 260. We'll call it 56. Okay, so this is the equation then that models that data. Then what do we do with the slope? How can we interpret the slope? A lot of times if you're doing something in the real world, it's not enough to tell, if you were presenting this information to somebody, let's say, it's not enough to just say, well, the slope was negative 22.97. Okay, pretend you're sitting in a boardroom and nobody has a clue what negative 22.97 means to them. Instead, when we interpret the slope, we want to put it back in terms of what was it that we were talking about. So remember that slope is about the y's over the x's. And in this case, my y values represented deaths from heart disease, and the x values represented the amount of wine we consumed per liter, or in liters. And if you'll come back and you'll set it up like this, then interpreting the slope becomes a little bit easier. Now that we know what our units are, let's go back and kind of look at the slope. The slope is negative 22.97, and we're going to write that over a 1 because it helps us interpret this a little bit. We know, though, that when we have a negative slope, my line is decreasing. So we're going to use that word, decreasing, when we interpret it. We also know that this is 1 liter, because that was the units for the wine that we were, for the x variable that we were talking about. Now this is 22.97 per 100,000, and we know that because if I scan over here, that's what it said in the y in this column, per 100,000. So let's change this number to something that's a little bit readable. And I am going to multiply it by 100,000. In other words, I'm going to move the decimal places over to the right 5 zeros, because you see 5 zeros up there. So 1, 2, 3, 4, 5. filling in with zeros. Now what do we have? We have something that means a little bit more to maybe me. So what do I have? I have, if I were to interpret the slope, I would say that each year there are 2,297,000 deaths. How about this? Let's say that each year deaths by heart disease decrease by 2,297,000 for every liter of wine consumed. So let me say that again. Each year, deaths from heart disease decrease by 2,297,000 for every liter of wine consumed. Okay, so using the units from what I know slope is, it helps me interpret it. Now the next thing that I'm asked to do is, okay, well, once we come up with the regression equation, can I predict then the number of deaths if somebody, the number of deaths for people that consume 4.2 liters of wine per year? And that's kind of the whole reason why we create models, is so that we can kind of predict what's going to happen given a model that fits the equation. So when we have a function like here, right, this is our linear regression function, and all I'm going to do then is replace x with 4.2. So I get negative 22.97 times 4.2 plus 260.56. And that gives me, when I simplify that out, 164.09. Now remember, I'm going to move the decimal place over just to make this a little easier to see. That would be the answer, 164.09 per 100,000, or 1, 2, 3, 4, 5. So I have 16,409,000 deaths from heart disease for people that consume 4.2 liters of wine per year. Okay, so I can predict the number of deaths. So this is a rather long problem to explain. It does go a little bit faster when you're working it on your own, but a regression is a very, very useful tool that we use not only in mathematics, but in statistics, in engineering, and in all sorts of other applications.